On RT3-1, we're going to learn what sine, cosine, and tangent are, and we're also going to determine side lengths and missing angles using those trigonometric ratios. So we're going to think back to our ancient Greeks, and if you've paid any attention at all this year, you'll know what a big fan I am. So we talked in January about how they had figured out, hey, if you have a 30, 60, 90 triangle, and that side is 1, this side is always 2. And if I have a bigger 30, 60, 90 triangle, the same pattern happens. If this side is 2, that side is 4. And if the short side is 3, the hypotenuse is 6. And they had figured out that that ratio was the ratio 1 to 2, no matter what, okay? And it was pretty cool, and they were all big fans of it. But then someone came along and they were like, you know what, we don't have the internet yet. All we kind of have is sheep and math, and that's kind of our whole thing. What if we changed the 30 to like a 29? What happens if this is 29 degrees and that side is 1? What's the ratio now? And so they figured out that in every single right triangle, no matter what the angle measure here is, you can figure out what the ratio of the sides will be, okay? And we're not going to learn what every single one is because that is insane, but luckily your calculator knows it. So it is stored in the memory of your calculator. Way back in the day, you used to have to look it up on like a chart, and you'd have like this big scary looking decimal. We're not going to do that. We're just going to use our handy dandy calculators. If you're curious, let me know, I'll get you a chart. So the ratios you need to know are sine, cosine, and tangent. They're abbreviated sine, cosine, and tangent. Notice, friends, I still said the entire word because that makes me sound intelligent. If I say sin, cos, tan, people will know what I'm saying, but they'll be like, who is your math teacher? And then you'll have to lie because I don't want to claim responsibility for that, okay? But that's what those buttons on your calculator stand for. We're going to talk about sine first. So if I have a triangle like this, there's my right angle, and A is over here. And I should mention these only work in right triangles for now. If that's angle A, the sine of A is the side opposite angle A, so across from angle A, so not touching angle A, divided by the hypotenuse of the triangle. So if the opposite side was 4 and the hypotenuse was 5, I could say the sine of A is 4 over 5. Okay, we always write it in simplest terms or as a decimal. We never leave it as an improper fraction or like a mixed number or anything weird like that. Cosine then, in that same triangle, if A was hanging out down here, there's my right angle. Cosine will be the adjacent side, which is the side that is touching angle A, so not the opposite and not the hypotenuse, divided by the hypotenuse. Tangent is my personal favorite, and we'll mix it up. We'll put angle A up here this time. Tangent of A will be the opposite side over the adjacent side. So the side opposite angle A in this picture would be down here because it's across from it. The side adjacent, that is not the hypotenuse, is the side that's touching it, but is not the hypotenuse. And if your adults went to school in the United States, they likely learned the phrase SOHCAHTOA at one point. So this is an acronym that helps us remember which one is opposite hypotenuse, which one is adjacent over hypotenuse, which one is opposite over adjacent. Okay, and I think it's really obvious, and most kids think it's really obvious, but I'm going to spell it out super, super obvious because last year I had a kid who light bulb didn't click until like day of the test. So I'm just going to make it a little more clear. The letter S in SOHCAHTOA stands for sine. And then the next two letters tell me what the rule is. So opposite over hypotenuse. Right, here's the O, there's the H. CA tells me cosine is adjacent hypotenuse because the C stands for cosine. And then the next two letters, AH, stand for adjacent hypotenuse. TOA helps me remember tangent because the T stands for tangent, and tangent equals OA opposite over adjacent. Okay, it is a good idea to write this on the top of your homework page, to write it on your scratch paper, to write it on all of your practice problems, to write it on your guinea pig's left foot, all that good stuff. Here's a joke about SOHCAHTOA versus COSATOA. COSATOA is not a thing. They're making a joke about forgetting it. If you don't think it's funny or you think it's confusing, that's okay, just delete it. If you do think it's funny, so do I. All right, we're going to practice this. So the first thing I'm going to ask for is the sine of A. So I'm going to find A, and then I'm going to think about SOHCAHTOA. Sine tells me, hey, use the opposite over the hypotenuse. So I'm looking for the opposite side, which is 3, over the hypotenuse, which is 5. Then they ask me, what's the tangent of A? SOHCAHTOA tells me, hey, use that opposite side 3 over the adjacent side. Adjacent is the side touching A, but not the hypotenuse, so it'll be AC here. And I don't have a side length there. And some of you are like, nah, let's just dump X in there and call it a day. And that's tempting, but if you do that on the test, you will be wrong and you will be sad about it. Instead, we're going to use the Pythagorean formula, and I'm not going to use red in case any of you are colorblind. So I'm going to do 5 squared plus, no, equals 3 squared plus x squared. So I've got 25 equals 9 plus x squared, or 16 equals x squared, which means x must be 4. Wonderful. On your checkpoint, on your test, make sure that you solve for that first before you throw it into your fraction. And then I'm asked for the cosine of B. So I'm no longer looking at A at all. I'm looking for cosine, and now my angle is B. So from B, I'm looking for the adjacent side. The side adjacent to B is 3 over my hypotenuse 5. And some of you are noticing, hold up, this can't be cosine of B because it was also sine of A. And friends, those things are always the same. So the sine of A is always the cosine of B. The sine of B is always the cosine of A, assuming they're in the same triangle. Cool. All right, we're going to practice solving for it now. So we figured out how to find those ratios. Now we're going to use it to solve things. And when I solve, I'm always going to go back to SOHCAHTOA. And I'm going to look at my picture and what I have. From my angle, I have the opposite side and I have the adjacent side. Opposite adjacent tells me, hey, use tangent. So the tangent of 28 degrees has to equal x over 20. And this is where some kids start to get kind of nervous because they're like, well, now what? If I gave you something like 28 equals x over 20, most of what you would know without hesitation, well, I just got to multiply both sides by 20. Algebra, boom. That drops out, cleared my fractions, clean it up, bada bing, bada boom, I've got x. It is no different when we throw tangent in. I'm still just going to multiply both sides by 20 to clear that fraction. And now 20 times the tangent of 28 equals x. And I want you all to do this with me. Don't just watch me do it, because this is a great way to check that your calculator is on the right settings. There's this thing called Radians that we won't learn until the very, very end of this year, maybe if we get to it. And it's kind of like working with feet versus meters. Okay, you can use either. They both measure the same thing. It's just a completely different way of measuring. If your calculator's in radians, all of your answers will be wrong. And you will be so sad, and I will make you redo the entire test. I will let you redo the entire test, but you'll also have to redo the entire test. And that sucks, okay? Check your calculator, check early, check often. If you grow up and you take the ACT and SAT and all those other big scary tests, okay, check at the start, check in the middle, check at the end, because if it's on the wrong setting, all your answers are wrong, and that's a bad time for everyone. So I'm going to do 20 times the tangent of 28, and I get 10.6. If you do not get 10.6 on yours, you're going to click on the little button that says switch, and you're going to make sure degrees is the one that is dark. If it looks like this, you're going to get the wrong answers. It's going to be a bad time. Okay. Cool. For the most part, I will have you round to the nearest tenth. Both on checkboards and on tests. If it is different, it will say exactly what to round to. So just read. All right, we're going to do another one. This time, I have the side adjacent to 40 degrees, and I have the hypotenuse, or I'm looking for the hypotenuse. Adjacent hypotenuse tells me, hey, use cosine. So the cosine of 40 has to equal 15 over x. I'm going to multiply both sides by x. So I get x times the cosine of 40 equals 15. And then I'm going to divide by the cosine of 40. This is why it's so important to write out your work. Because if you accidentally did 15 times the cosine of 40, or cosine of 40 divided by 15, because you flipped this fraction in your head, I can't help you find that mistake. If you write it all out, I can help you see that mistake and figure out where you went wrong. Okay? And likewise, you can go back and find your own mistakes too. If you do it all in your head and all on your calculator, I can't help you because I can't see inside of your head yet. I am working on it. I'm going to type in 15 divided by the cosine of 40. And I get x must be 19.6. Now we're going to do one where we're looking for the angle. So I want to know what that angle measure is. I have the opposite side, and I have the hypotenuse. SOHCAHTOA tells me opposite hypotenuse, use sine. So the sine of angle A, and I'm just going to put A in for my variable right now, has to equal 8 over 16. And if I want to reduce that fraction to 1/2, because I'm a big kid, I sure can. When you undo addition, a lot of you think of it as subtraction because that's what we call it, but you're really doing the inverse of addition. Okay, when you undo multiplication, you think of it as division, but you're really doing the inverse of multiplication. When you undo sine, you're doing the sine inverse. Okay, and your science teacher, depending on who you have, might call it arc sine. Actually, I think most of our science department does. That's fine. They're allowed to call it arc sine and inverse sine are the exact same thing. It's just, are you more old school traditional or are you like hip and trendy? I personally like to be hip and trendy. So I'll call it sine inverse, but if you call it arc sine, that's fine. I'll just know your science teacher beat me to it. And I'm going to do the inverse sine on both sides. And I write it as sine to the little -1. And that button is right here on that calculator. If you're not using your iPad calculator, on your handheld calculator, you will need to hit second sine or second cosine, depending on which one you're doing. Okay, it is not sine with an actual -1 exponent. You'll get weird things happening then. Sine inverse and sine will cancel each other out. So I'm left just with a over here. There's no sine to cancel out on this side. So that entire thing has to stay. And some of you are freaking out because you're like, okay, now what? Okay, how do I do that? How do I do sine? You don't do sine, you look it up. And the way you look it up is through your calculator. Your calculator has programmed in it what the inverse sine of 8/16 is, what the inverse sine of 9/16 is. They have all of that in there. Your computer or your calculator's memory is actually pretty big. So I'm going to type that in. And when I hit enter, bada bing, bada boom, my calculator spits out the answer. Okay. I can check this by saying, okay, is the sine of 30 the same as 8/16? And it sure is. There's a few Greek letters that you should know. One of them is theta. It's a circle with a belt on. It makes the th sound in Greek. The other one is beta. It makes the b sound. It's like a B, except you rounded the top and made a tail and didn't quite connect it at the bottom. If you take German, it is also the double S sound. Okay, but in Greek it says B. And then the other one you should know is alpha. It looks like a little fishy. It makes the A sound in Greek. And we use these simply because we ran out of English letters, okay? We needed more variables. Think back to like kindergarten, and your teacher probably at some point had something like triangle plus 1 equals 3. What's the triangle have to be? And you were all like, it's 2. This is so much fun. Kindergarten's amazing. Because if she had put up, well, x plus 1 equals 3, you would all be like, hold up, what's an x? I don't understand. I'm scared. Okay? But then you got to 4th, 5th, 6th grade, and we started doing stuff like this, where we put the alphabet into math, and it was a good time. And now you're a big kid, and we're like, you know what? The alphabet's not big enough. We needed more letters. So when we're looking for angles, since the Greeks were so into angles, why don't we use some Greek letters? Okay? That is literally the only thing. It works the same as any variable. So now we could say theta plus 1 equals 3, and you're big enough to know that it's not scary math. It doesn't mean anything different. It's just a variable, just like x or y or z or a. Okay, we just needed more letters. Cool. There is a link down here and on your notes to a very catchy and kind of annoying song, if that helps you. You have a checkpoint to work through. Make sure that when you have a problem like this where you're finding the ratios, you solve for that missing side first. Don't